Welcome back to Nature and Code. We're in Chapter 7, Epidemics, and we just implemented this run time step method here, which will run each time step. And we've set up everything with a temp grid and a grid, and now we just have to implement this function expose neighbors. So this function will be called whenever we hit on an infected individual, and we now need to expose all of its neighbors, and this individual lives at coordinates I and II. So let's go ahead and implement this function. Okay, so we have function expose neighbors I and II. These are our coordinates. Okay, so who needs to get exposed? So as we've seen before, we are going to expose the neighbors in the cells right next to the individual that we found to be infected. And you may recall, again from chapter 5, how we did this. But it's fairly straightforward, and I'm just going to do this here real quick again. But, here we have our 9 cells. So this here is I and II. Then the 8 cells here that will be exposed have the coordinates I minus 1, II minus 1, I minus 1, and II, and I minus 1, and II plus 1. Likewise, here we have I and II minus 1. Here we have I and II plus 1. And finally, here we have I plus 1 and II minus 1. Here we have I plus 1 and II. And here we have I plus 1 and II plus 1. So these are the coordinates here, given this couple of coordinates, this pair of coordinates. So what we're going to do is we're essentially just going to loop through this sort of mini 2-dimensional array here of 3 times 3 cells. We'll have to take extra care that once we're here, we ignore this particular cell because that's the infected individual and it cannot reinfect itself. And the other thing that we need to make sure, as always, right, we have this border issue here. So potentially, here, this could be our actual border of the grid. And so we want to make sure that, if we move from here to here, we actually re-enter on the other side of the grid and we don't get some funky array mistakes here. And again, this is the exact same concept that we implemented in chapter 5. So if this sounds completely unfamiliar, be sure to check out the corresponding video in chapter 5. So let's go ahead and implement this. Okay, so back to the code. Expose neighbors. So what I need to do here is I need to loop now through these 9 cells. So I'm going to do this as follows. I'm going to say for var, and now I know I usually start this with var I equals something, 0 typically. However, I already have I and II here that I'm passing in as parameters. So I'm going to use another variable here. I'm going to call this ni. And I don't want to start this loop actually at 0. I want to start it at I minus 1, because that's where I want the grid to start. And then I'm going to say, well, as long as this ni is smaller or equal to I plus 1, right? This is our maximum value. And then, as always, I'm going to increase this ni by 1. Okay, so this is the exact same logic, except that now we have, I'm going to add spaces here for better readability, that we have this new variable ni. But we have implemented all these loops now over many chapters, and you should now understand this quite well. We basically just start here at a given value, the minimum value, that's I minus 1. For each iteration, we increase this value by 1. And then once we hit this maximum value, I plus 1, we're going to stop. So this is going to, loop or iterate exactly 3 times, as we, of course, want it to. So now I'm going to do the exact same thing, except with I. So I'm going to set up this variable var nii, which starts at I minus 1, and then nii should be smaller or equal to I plus 1, and then I'm going to increment nii after each iteration. All right, so now our nii couple or pair is now the coordinate of the neighbor, right? So going back here to this, we are now sort of looping through these values here. Okay. In that order. So we're going from here to 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 here. Okay. Now we said we have to take care of one special issue, and that is if we're actually at the cell in the middle, at the center. And that of course happens when ni equals I and nii equals ii. So when they are the same, then I am at the center here of this mini grid. So if that is the case, basically I just want to say, don't do anything. Just go on. And the keyword for that, and that's a keyword that we haven't encountered yet, is continue. But continue is a keyword in JavaScript, and you can see this here in the syntax highlight. My editor recognizes this as a keyword, and hopefully yours does too. So this is a keyword in Java that you can use if you're in an iteration and you want to say, well, if a certain condition is true, continue, which will just mean that the current iteration is going to be aborted, but the loop keeps on going. So whatever we're doing at the moment in the iteration, stop it and just continue with the loop as if nothing happened, which quite often comes in very handy. And this is a good example, I think, here. So we're going through all these cells. Now we're at a particular cell. In this case, we don't want to do anything, so we can just say, okay, continue. So everything will be aborted, and we continue with this loop. All right, so now I can what exactly will be aborted? Well, whatever we still have to, in this iteration, and that is something that I will call try infection. So try infection is a function where one individual will try, quote unquote, to infect the other. So remember, we have our infected individual here, given by these coordinates I. We are now iterating through all its neighbor individuals, and then we say, okay, now please try to infect this neighbor individual. And I'm just going to sort of outsource this into a function. So what does this function need? Well, it simply needs the coordinates of this individual. It doesn't need to know the coordinates of I and ii anymore. We're good. We've used those coordinates now for the purpose of finding the neighbors. We know that the individual is infected. So really, we just need to know, okay, try infect which individual, which coordinate. Well, of course, we now know it's ni and ii. So let's pass these in as the coordinates of the potentially newly infected individual, the individual that is now being exposed. Okay, and now that we're doing this, why don't we actually pass in the correct coordinates right away? So by correct, I mean the coordinates that have been checked for their validity within the grid. So if they're outside of the border, then they have been, recalculated to be within the larger grid. And remember how we did this in chapter 5. And I'm actually going to open this file now. Open chapter 5, spatial simulation. Remember how we did this? We did it with this function get bounded index, which is really handy, right? You pass it an index, a coordinate, so to speak, in the grid or wherever, could be outside of the grid, near the border, and then it will check if it's actually within the borders, and if it's either, if the index is either too small or too large, so it's outside the borders, then it will calculate the corresponding correct index, assuming that the individual, that the borders are actually wrapped around. So let's just copy this function and go back here to our epidemic, and we're going to just paste this somewhere. Okay, I'm going to paste it here. So let's go ahead then and pass the bounded indices to this function try infection. So I'm simply going to say get bounded index ni, and similarly get bounded index nii. Okay, so what we have to do now is to implement this function, try infection. Try infection, and I'm going to call these now again, these parameters, these arguments I and ii, because they're simply coordinates. So the first thing I have to check is, well, is that individual susceptible at all? Because otherwise there will be no infection, right? So if this individual grid is susceptible, only then can this infection actually occur. And it does occur with a certain probability, and that probability is beta, right? So now we can just simply say if math random is smaller than beta, then we have an infection. So now we're going to set this individual here, the state of this individual, to I. And that's it. So as simple as that. And this should now work. So we should now be able to save this. And I'm going to close this tab here, and I'm going to close the spatial simulation. Okay, save it and go back to the browser. And now reload my document. And you should reload yours. And you should now see some form of infection. However, nothing's happening here. So we need to figure out what exactly happened here. There must be a mistake somewhere. Let's take a look at View Developer JavaScript console. There is no error whatsoever. So let's go back. The error seems to be somewhere in the logic. So let's see what we have here. We have the function simulate and visualize. It will be executed every 50 seconds. So let's make sure that this happens at all. So I'm going to write here console log, then just say in SV, simulate and visualize. So let me save this, reload. Yep, this definitely seems to be happening here. Okay, so that's good. Let's see what we have here in this runtime step. Okay, so runtime step. We have the temp grid. That seems to be working fine. We have the expose neighbors. I don't see a mistake here right away. So let's see if we have something in the expose neighbors. So let's go to that function, expose neighbors. Okay. So let's see that actually this function gets called console log expose in expose neighbors, save, reload. Yes, this is called as well. Okay, so let's see. Let's go to the next version. So this is again this divide and conquer. So we would like to say try infection if these are not the same values. So let's go to try infection and see what happens here. So in try infection, this should also occur many times. Also works. Okay, so let's see. If this individual here is susceptible, then we say, well, if math random is smaller than beta, then we're going to update the grid. Oh, no, we're not updating the grid. As we said, we're going to update the temp grid. Okay, I'm pretty sure that was it. All right, so once again, I kind of apologize, but then at the same time, I'm really glad that these mistakes happen, because they will happen all the time. And I'm sure they happen when you code as well. And one of the key aspects about programming is to find out where the mistakes occur and fix them. All right, so let's go back, save this, reload, and here we go. So here you can now see our epidemic spreading through the population, and very quickly the entire population will be infected, and it's happened now. And you can reload this as many times as you want to. Of course, the exact same thing will always happen. Why does it always happen? Well, because it is guaranteed that you will eventually get infected, because the infected individual will remain infected forever. And so each infected individual is guaranteed to eventually infect other nearby susceptible individuals. All right, so this is only half of the story, because we now have our infection working. So what we need to do now is to implement the recovery. That's actually much simpler, but we'll do this in the next video. See you in the next video.